Okay, so for today we are going to discuss the most important part in our function chapters, right? So we call it as inverse function. Okay, so inverse function part generally, I believe that most of you learned it before as well, but they again try to bring in the concept of domain and range into our function here, into this kind of question, and usually it can be quite complicated. That's the first thing. And the second thing is they also try to introduce the inverse function for quadratic expression. I believe that maybe sometimes time when you learn, right, most of the function that you learn doesn't involve the quadratic expression, or maybe it is a simple type of quadratic expression. Okay, so for now, they introduce a quadratic expression for the inverse function plus the domain and range. So actually there are a lot of things that can be tested. All right, so they want to test your understanding about the domain and range. They want to test about the inverse function for the quadratic. Then a lot of questions from this chapter actually is coming from inverse function part. Right, composite function they will ask you but not so many. Okay, but they will focus mostly on the inverse function part. All right, so please make sure that you try to understand, okay, all the domain and range part under this inverse function. Okay, right, so let's start with it. Okay, so for today's learning outcome, for this video's learning outcome, first you have to understand what is the meaning for one-to-one function. We learned about one-to-one relation before, right? So now you need to know what is the meaning of one-to-one function, and you also need to know what is the meaning of inverse function. Okay, so you have to determine whether or not a given function is one-to-one and find the inverse function of a one-to-one function in simple cases. And after that, they also want you to illustrate in graphical terms the relation between a one-to-one function and also the inverse. Right, so for today's video, we'll focus on the first two learning outcomes, and the graph part we'll cover in the next video or maybe in the next lesson. All right, okay, so let's start with the inverse function part. So inverse function means that when you are sending the x to y by using a relation function, when using a function, then the inverse function means that you map it in a reverse way, which is you map y back to x. So if I want to use the arrow diagram to represent the inverse function, that it will look something like this. Okay, so let's say I'm having x1, I'm having x2, x3 here. And then after that, I want to map the x1, x2, x3 to y1, y2, y3. Okay, so generally, we will label this as function f. Okay, the red color one, I will label it as function f. Okay, so if let's say you look at the function f, you know that this starting value here will be the domain of f, and this ending value here will be the range of f. Right or not? So this is what we have. Okay, then next, how about if I want to send the value of y, okay, back to the x here. Okay, so if I want to map y back to the x, so maybe I use the other color, so maybe blue color, so y map back to x. Okay, so there's another function also. So this function is opposite direction with the function f, right? So we usually call it as f inverse. So this is the meaning of inverse function. That means it is in the opposite direction of function f. Okay, all right. So when you're having the f inverse, right, that means the y set, the set of y here will become your domain of the inverse function, correct or not? Therefore, when you write it out, this is actually the domain of the inverse function. And for this part, it will become the range of the inverse function. So you can write this is the range of the inverse function. So from this figure, there are two important results that you must know, and it is very important. You will see that the domain of f and the range of inverse are actually the same set. And then the range of function and the domain of the inverse function is the same set of value also. Therefore, they come up with a conclusion which is very, very, very important in our syllabus here. Okay, so please make sure that you highlight and memorize these two results. Okay, so this is what we have. That means now the domain of function is equals to the range of the inverse function, and the range of the inverse function is equals to the and the range of the function will be equal to the domain of the inverse function. So this is super important and make sure that you remember it. Okay, all right, so now we'll apply this later. I will discuss a few examples with you and then you will see how we apply this. Okay, so next, when you want to find the inverse function, right? Last time you just find out, right? Okay, when I say, okay, find the inverse function, so you just try to find it out. But for this one, you need to know that the inverse function only exists if it is a one-to-one function. Okay, so how to decide whether is it one-to-one or not? So there are a few methods for you to to decide. So to determine, the first one is the algebraic approach. Again, algebraic approach usually you need to have a lot of math knowledge to decide. Okay, to be used. So usually I will focus on the graph. So the graph one is the horizontal line test. So horizontal line test means that it's a simple test. That means when you are having the graph of your function, you try to draw a horizontal line. If let's say the horizontal line and intersect the graph only once, that means you are having the one-to-one function. Okay, so as an example here, this graph is not good enough. So maybe I will just redraw it again. So maybe I'm having this graph now, getting closer and closer to the x-axis, but it will not touch the x-axis. So how to decide whether this graph is one-to-one function or not? Then to decide, you just draw a horizontal line. Okay, and then you use your ruler to put on the horizontal line and move it up and down. So no matter how far you move up or move down your horizontal line, you will see that they only intersect at one point with the graph. So every time if they only intersect at one point with the graph, that means this is a one-to-one function. So one-to-one function, I write it like this. Please write it out. One-to-one in exam, right? So one-to-one function. Okay, so for example number 2, if let's say you draw any horizontal line and then you try to move it up or move it down by using the ruler, okay, no matter how you see that, mostly they are having two intersection points. So when you're having the horizontal line and two intersection points with the curve, that means what? That means this is not a one-to-one function. Okay, so if let's say you are having this kind of graph, which is not a one-to-one function, then you cannot find out the inverse function. So the very important condition that must fulfill is what? To find out the inverse function, it must be a one-to-one function. So I believe that this is something that you didn't learn before. Okay, and they are very particular in this. They will actually ask you to decide whether can you find a one-to-one, can you find the inverse function or not for a particular function that they give you. Okay, all right, so let us continue further. Okay, so as an example, like example 12, they want to show that the following function are one-to-one or not one-to-one function. Okay, so again, if you look at the example, the expression here, both are also x squared. Then again, because of the domain are different, therefore your graph will be different also. Okay, so for part A, how will your graph look like? So I think I told you before already, right? The domain will actually affect the pattern of your graph. Okay, so they are still U-shaped here, and then the domain is negative to positive infinity, so you just keep it as a U shape here. And then for part number 2, okay, you are having also fx equals to x squared, but they are looking for only the x greater equals to 0. So if x greater equals to 0 means that this is your original u square. I think you should be very expert with it already. And now this is the part for x greater or equals to 0, right? So that means you would want to ignore the graph on the left hand side. And therefore your graph will look something like this. It is a U shape, but only part of it, half of it. So this is y also equals to x squared. Alright, so which one is the one function? So very obvious, if you draw a horizontal line, is this a one-to-one function? No, this is not a one-to-one function. Then how about for part number 2? When you draw a horizontal line, yes, there's only one-to-one function, right? There's only one intersection point. So this is a one-to-one function. Okay, so that means later, when they want you to find the inverse function, right? Although both are having the same function, same expression here, but only this one you can give them the inverse function answer. This one you cannot give them the inverse function answer because it is not a one-to-one function. Okay, and then maybe sometimes the question will also ask they maybe give you something like this y equals to x squared, and then maybe they said x greater equals to 8, let's say, but they didn't give you the value of a. So they will ask you what is the value of a that you should put in so that this function will have a inverse function. So they will ask you something like this. Okay, so this is the part where students usually they will feel very confusing. All right, so you have to know, in your mind you need to have the graph, and then you need to know until what value you have to draw so that your graph will have a inverse function. Okay, so this is something that they might ask you in the exam. Okay, right, but no matter how, this is the first step to decide whether do you have inverse function or not, decide whether your function is one-to-one or not. Okay, so this one very obvious. You'll see that part B is one-to-one function, but for part A, it is not one-to-one function. Okay, all right, then next one. Before you go to the main part, when in the exam, right, when you want to decide whether is it a one-to-one function or not, you no need to purposely go and draw all the graph here. They won't give you any extra marks for this. So all the graph here, all the methods here for the one-to-one function is to actually guide you or give you an idea how we decide actually. So usually I will use a graph. I will imagine the graph in my mind and I try to draw the horizontal line. Why you no need to show it up in your exam solution. Okay, all right, so let's continue to the next part. Okay, so for the next part, they want you to find the inverse function. So there are a few methods for us to find the inverse function. First, you can use the formula f and f inverse x equals to x. Okay, so this is one method. I don't know how many of you are using this one. Okay, you have to know that because when I start with f followed by f inverse composite function, we'll get back the original value. Therefore, f and f inverse x equals to x. Okay, and then usually I'm using the second method. So what I do is that I will let fx equals to y. Then after that, I find x in terms of y. So like what I shown you in the previous video. So, right, y equals to something something x. After I rephrase it, I will want to change it become x equals to something something y. All right, then from there, that is my inverse function answer. Okay, all right, so let's start with a few examples that is related to inverse function first. Okay, we'll look for example 3. Okay, so for example 3, this is the graph that I'm having. Okay, all right, so it is in x power 3, the cubic function. So usually for cubic function, it is not so hard one. And then they are only considering the range the domain from 2 until 4. Okay, so if you want to know, if you want to know the idea, maybe you can imagine the graph in your mind, or maybe you can try to sketch a simple graph. Okay, to help you first. Okay, so let's say I'm having when my x is equals to 0, what will happen to the y? When my x equals to 0, the y is negative, right? Very negative. Okay, so never mind. I will roughly draw the graph like this. Okay, so let's say this is 3 over 2. This is negative 8. By using the idea of transformation of graph, I know that my graph will look something like this. Okay, and then this one. This is the cubic graph, correct or not? Okay, then now because of my value here, they only want to consider 2 until 4. So that means you substitute 2 inside. So you're having 1 minus 8, which is negative 7. So that means that if I have 1 here, this value that I get is negative 7. Okay, then after that I substitute a 4 inside. 4 times 2 is 8. 8 minus 3 is 5. So 5 power 3 is 125 minus 8 is 100 something. Okay, so never mind. This one is a 4. This is a 2, right? So this is a 4. So when you're having a 4, this value will be 125 minus 8 117. So generally, this is the part of the graph that they want you to consider only in this question or this function. Okay, so again, x power 3 is having a long graph like this, but according to the domain that they give you here, your graph will look something like this one. So I cancel off the red color one. Oops, okay. So no matter how, right, in exam, if you didn't draw this, it's okay. All right, but I just hope that every time when you want to answer this kind of question, at least you have a shape of the graph in your mind so that you roughly know, okay, you can imagine a bit. Okay, so this is a part of the graph that I want. So if you look at the graph, is it a one-to-one function? Yes, it is a one-to-one function, right? Because when you draw the horizontal line, there's only one intersection point. Okay, so find an expression in terms of x for f inverse. Okay, so when they want to find the f inverse x, so how can I find it out? For cubic equation, there's nothing special. You just let y equals to 2x minus 3 power 3 minus 8. Okay, you try to rephrase everything. Become x equals to something something y. So I bring the 8 over. And after that, I need to take a cube root. So cube root means like this. When you take the cube root, you don't need to consider plus and minus sign. Only when you're having even number root, then you need to take plus and minus sign, like square root. Okay, it's even number, right? 2. So plus and minus sign. Then maybe root of 4, also the same. You might have the plus and minus sign. So the odd number no need. Okay. Then after that, what is the next step? You have 2x equals to 3 plus cube root of y plus 8, and after that x is equals to half. Then 3 plus cube root of y plus 8. Okay, so this one, it is a cubic function. There's only one answer here. Therefore, you no need to purposely go and choose which is the correct answer. This is the only answer that you have. So you're having 1 over 2, and then you're having 3 plus cube root of x plus 8. So this is your answer for inverse function. Okay, then after that, what else do we have? They ask you to find the domain of inverse function. All right, so to find the domain of inverse function, you need to use the concept that we learned just now. And I said, which is very important one. So the domain of inverse function should be equals to what? Equals to the range of the function. Okay, so what is the range of the function? Okay, so again, because just now you try to use a transformation knowledge and sketch a graph already, right? So your original graph is this one. So where is the range? So you see that the range are covered from -7 until 117. Correct or not? So this is the range of f, which is from -7 until 117. Therefore, this range of the function is equal to the domain of the inverse function. So when you write it out, you need to use the number, which is -7 until 117. Because for domain, we are always talking about x, value of x for domain. Therefore, you cannot write the y here, you have to keep it as x. So this is the domain for inverse function f. So how I know that it is from -7 until 117? It is from the result that we learned just now, which is the domain of inverse function to be the same as the range of function. Okay, so I hope that you have the idea. Then again, how I get all this value here, the graph. So again, if you didn't sketch the graph, they won't penalize your marks. If you sketch it, they also won't add up extra marks for you. Just that, in my opinion, right, if let's say you have a graph in your mind, or maybe in your steps, at least you can imagine it better. Alright, so that's why I teach you in detail how to actually use the transformation of graph and try to draw all the graph here. Alright, so we are going to use it very often here. Okay. Alright, so this is what our example 13. Hopefully you have the idea and roughly know okay, the style okay, of A-level inverse function question. Okay, let's continue to another example. Example 14. Okay, so for example 14, they want you to find the quadratic expression in this, that means in the completing square formula. Again, I will leave it for you. You have x minus 3 squared, then minus 9. Alright, and part number 4, they want you to find the inverse function and also state the domain of H inverse. Okay, so again, before I start, I will try to sketch the graph, maybe somewhere in my solution or in my mind first. So I'm having x minus 3 squared minus 9, which means if let's say I try to sketch it, my graph will look something like this. So let's say this is a 3, and this is negative 9, let's say. Okay, so when I have x equals to 0, 0 minus 3 squared is a 9, 9 minus 9 is a 0, so my x-intercept will be here. Okay, so equation will look something like this. Hey, my ratio very weird. Can I draw it better? Okay, so maybe I assume that this is negative. Alright, and then my graph will look something like this. So correct. This is my original graph for x minus 3 squared minus 9. Okay, so they want us to find the inverse function, but this U-shape is not an inverse function, right? So you have to look at the domain. What is the domain that they give you here? X greater equals to 3. So x greater equals to 3 means that they only want you to consider from this point. Greater equals to 3 means that they only want you to consider this part of the graph. Okay, so this is the domain that they give you. So your graph will finally something like this only. So it is a one-to-one function, right? So that's why they will ask you to find the inverse function. Okay, all right, so they already decide the domain for you and your graph will look something like this. From the graph, you know it is a one-to-one function. That's why they will ask you to find the inverse function. Okay, so how can I find the inverse function again? Okay, so this is the inverse function for quadratic, right? So I think I told you before also, to find out the inverse function for quadratic expression, there's only one way, which is you have to do the completing square. There's no any other way. Okay, so we'll start here. Method is still the same. So you'll let y equals to this completing square pattern. Okay, so next step is you want to bring everything over. When you want to take square root, you have to include the plus and minus sign. And after that, you will have x equals to 3 plus minus y plus 9. Okay? All right. So now, this one, you should know that when you're having plus and minus, right, generally you're having two answers. One answer is 3 plus square root something. Another answer is 3 minus square root something. So the square root something will always give you a positive value. Okay? So 3 plus square root something and 3 minus square root something. So from these two functions, you can choose only one to be your final answer for the inverse function. Okay, so how to choose which is the correct inverse function for this question? Okay, so just try to link it. So this is the inverse function formula, right? Okay, and you usually will assume that these are the range of the inverse function, the formula itself. But when you want to write the range, you must have the value. This one is a general one, okay? So this is a range of the inverse function. It should be the same as what? It should be the same as the domain of the function. Okay, All right, so what is the domain of the function? So the domain of the function is x greater equals to 3. Okay, then to choose from these two answers, which one will give you the answer more than equals to 3? 3 plus something is more than equals to 3, or 3 minus something is more than equals to 3. Which one? Only one answer, right? It should be 3 plus something, right? So it should be 3 plus x plus 9 will be your final answer for the inverse function. Okay, understand what I said or not? So there are a lot of small details here that you need to know lah. So to choose the range of the inverse function, you need to refer back to the domain of the inverse function, whether you should choose the plus one or whether should you choose the negative one for the quadratic inverse. Okay, then after you know you have to use the idea lah. The range of inverse function equals to the domain of the function. Okay, and therefore you choose 3 plus something because 3 plus something will give you the answer for more than 3. 3 minus something will give you the answer less than 3, right? So you should consider the answer 3 plus something. Okay, so this is how we actually choose the correct inverse function for quadratic expression. And in exam, most of the time they will ask you this because a lot of students might not know how to choose it correctly. Okay, then after that they are asking for the domain of H in. Okay, so let's continue. Domain of H inverse is equals to what? Is equals to the range of the original function H. Okay, so I want to know what is my range for the original function H. So from the graph that you sketch just now or in your mind, you know that the smallest value is -9 and the graph keeps on going up, right? Therefore, the range of the H is y greater equals to -9. So you can use back the same value for the domain of H inverse, but you change it become x. So you have x greater or equals to -9. All right, so this is a very good example to tell you about how to find the inverse function, okay, for a quadratic expression. And also you must know how to determine the domain and range for the inverse function as well. Okay, so this is what we have. Then next example, example 15. Okay, so like for those who already roughly have the idea, you can have a try for example 15 first. You pause the video here, and after that only you come back to the discussion again. Right? Okay, so this is a function that we have lah. Function fx. First, they want you to express it in the completing square form. So can you see that completing square form is very important because it always been asked in the exam. All right, so again, same rule, please complete this yourself. I'm having 2x minus 2 squared plus 3. Okay, then after that, they want you to state the range of f. Okay, so to state the range of f, again, how can we state it out or how can we find out the range of f? So generally, I will still draw a graph to help me. Okay, so according to the completing square form that we have, I know that my value is at minimum point is at 2 and 3. Okay, so this is the original graph for function fx. So to state, only state, right? No need to set, no need to sketch a graph for them. You only state the value that you think that the answer is. So again, for this one, to state the range of f, if you look at the graph, the smallest value for your graph is 3. Okay, and then your graph will keeps on going up also. Therefore, the range of the function f is y greater equals to 3. Very simple. One mark only the answer mark. Okay. Then part number 3, they ask you to explain why f does not have an inverse. if you look at the graph that I sketched, just now you actually have to also refer to the domain. So the domain is x can be any real number. So you need to consider the whole U shape, okay, in your fx. Okay, so they're asking you why this one don't have any inverse function. What is the reason? So very obvious. So if you draw any horizontal line, go through the curve, you will see that most of the time they're having two intersection point, right? Yeah, so that means this is not a one-to-one function. That's why they don't have inverse function. So you can write down it is not the one-to-one function. It is not a one-to-one function. Okay, so this is a standard answer one. Usually when they ask you why this one don't have any inverse function, then usually the standard answer will be it is not a one-to-one function. Okay, so far okay, huh? All right, then now, so fx don't have any inverse function. So this is a graph of fx. It is not one-to-one. Okay. Then now, the function g is defined as this one also. So if you compare function f and g, the expression is the same. But what is the difference now? The difference is about the domain. So for function fx, the domain is any real number. The function g, domain is x smaller equals to a when a is a constant. Yeah, so this is a question they like to ask. So now, a you don't know, right? They're asking you state the largest value of a for which g has an inverse. Okay, if I want to have an inverse function for my g, what is the value of a that I can have? So you refer back to the graph here, this is fx when you consider everything. So now they want you to decide a value so that you can make this function to have, okay, so to have an inverse function. So you have to make it become one-to-one function. Now, how can you make this graph become one-to-one function? So most of the time, because if let's say you want to make it one-to-one function, there are a lot of options. You can make it become x smaller than, let's say, -1. X smaller than -1, this part also a one-to-one function, right? Okay, there are a lot of selection. But for this question, they are asking for the largest value of a. So when they ask you for largest value of a, usually we'll consider the middle. Okay, the middle or the symmetry line of the parabola. Okay, so at this point, it is in the middle, right? It is the center of your U shape. So you can imagine that if let's say x smaller equals to a, that means they want you to consider the left-hand side of the curve. Okay, so if let's say you, you consider the x smaller than a means you want to consider the left-hand side of the graph. So which means your graph finally will look something like this. So what's the value of a that you should consider here? This is 2, which should be your a. Because if you put x smaller equals to 2, then you will see that your graph is being cut into half and you are having a one-to-one function. Okay, so the answer for A is equals to 2. Again, no steps that you need to show, but you need to do the analytic thinking, analyze. You have to analyze the answer by having your graph in the mind. Okay, all right, so this is a question that they really like to test students because they understand a lot of students, they might not be able to get the answer correctly. All right, or maybe they cannot imagine. So that's why they found it's quite good to ask the student to think about it. No need to show them any steps. You just write out the answer will do. Okay, so the answer for this one will be a equals to 2. Okay, all right, so your domain is actually x smaller equals to 2. Okay, then now, when a is having this value, they want you to obtain the expression for g inverse. Okay, so again, you need to start with the completing square. So what's the completing square for this question? You are having 2 and then x minus 2 square plus 3. Okay, then you have to move everything over. Okay, so you're having y minus 3 divided by 2. And then if you continue further, then you will have x minus 2 equals to plus and minus sign square root y minus 3 divided by 2, and after that you are having this. Okay, so sorry, I rephrase it again. Move the 2 over. Okay. All right. So again, from here, you know that from this part, you're having two answers. 2 plus square root something, and also 2 minus square root something. So which one is your correct answer for the F inverse? Again, you look at the domain. So the domain is x smaller equal to 2, right? So 2 plus something will be smaller than equals to 2, or 2 minus something will give you this answer. So I think very obvious also, you should know that 2 minus something will give you this answer. So it become x minus 3 divided by 2. So this is an inverse function here. Okay? All right. Then after that, what else do they want? So they want you to find the range of the inverse function. Okay, so again, the range of inverse function equals to what? Equals to the domain of the original function. What is the domain of the original function? This one. Therefore, you can straight away write out the answer very clearly. The range of the inverse function will be range, so it should be y. So you are having y smaller equals to 2. Okay, so this is what we have, a complete process, okay, about a particular question where they want you to decide the domain yourself so that you can get an inverse function. All right. Okay, and this kind of question is very famous in A-level syllabus, I think, because almost every year they will ask you the question like this. All right, so you can actually find out a lot of questions in your tutorial also from past year series. So you can try, select the question and try. I think you need to try a few more questions so that you're familiar, okay, with the process and everything. Then hopefully you get the idea that I want to show it to you here. Okay, then got one more thing that I want to mention before I stop the video for this part. Here, from here to here, you want to take square root, right? In the exam, please make sure that you show them the plus and minus sign. We want to do the square root. You want to take the square root on your own, so you have to make sure that you include, or you must show them the plus and minus sign for the square root here in your solution. Because for this step, they'll give you 1 mark. If you didn't write it out, you lost 1 mark. Usually the marking scheme will allocate 1 mark for this. Okay. All right. So here we we finished discussing the questions which is related to the inverse function. Okay, and then before we go to the next part, next video we are going to discuss the graph for the inverse function. So I hope that you can get yourself familiarized with the inverse function part first, because later when we want to bring in the graph, again you have more things to consider. All right, so please make sure that you are very clear about all the details here. Okay, so that's all for this video. See you again in the next one.